Alright guys, so we're starting a new unit today. We're going to cover transformations and translations. This whole unit is about how a figure shifts or moves on a graph. It can also be about how things are made larger or smaller. We kind of talked about this in a previous unit, calling it scale factor. In this unit, we're going to refer to it as a dilation. So let's start up here at the top. A transformation that does not change the size or shape of a figure is called rigid motion. So if you have a translation is sliding a figure either to the left or the right or up or down. So you can see we just moved this one over and then shifted it up. So this would be rigid motion. A reflection is a flip over a line. So here they took the original image right here and they just flipped it over. So they flipped it over this line right here, which is the y-axis. This is also rigid motion because the size of the shape and the did not change. Down here on a rotation is a turn about a point. So here they took the original shape right here and they rotated it down into this quadrant. So if you can kind of imagine rotating like that, you end up with it in this third quadrant on the graph. See how the image looks there? So if we rotate, now it looks the same. So that's a rotation. Again, the size didn't change on the shape, so this is also rigid motion. Now a dilation is a shrink or a stretch. So dilations are when you zoom in on a picture on your phone, or when you go to the eye doctor and they dilate your pupils so they can see into your eyes. They're making that pupil larger, or you're making the picture larger. So you're actually changing the size of the image. So since the size has changed, this is not rigid. Alright, so let's do some examples of transformations. So on the first one, we're going from the point P, which is up here. We're going to a new point, which is P prime. And you can tell which one is the original and which one is the new one, because the new one's going to have this little tick mark up there at the top, and we say that is prime. So let's figure out how much we moved this over. So we're going to go from the new point, we're going to go over 1, 2, 3, 4, 5, 6. So we went that way 6. And then we're going to go down 2. I'm sorry, that's 1. So we're going down 1. And I still wrote 2. Good Lord, guys. Okay, there we go. I'm sorry. Alright, so we went down 1. So our new point is here. So we're going to figure out where this new point is. So 1, 2. And then up 1, 2, 3, 4. Alright, so we're going to do the same transformation to all of these points. So for Q, we're going to go over 6 and then down 1. So we want to find that new point right there at Q prime. So it's going to be at the point 1, 1. And then the same thing from R to R prime. So R what goes over 6 and then down 1. So this is going to be 1, 2, 3, 4, 5, 5, 2. Alright, so we talked about how they slid over. It went over 6 and down 1. So this algebraic rule is what we did to the x and the y coordinates for each point to go from the original to the new. So we went over, let's write this in green. So we went over 6, which means that we added 6 to our x coordinate. So you can kind of see here, if you took this -4 where P started and you added 6 to it, -4 plus 6 would give you a +2, which is what we got. And then for the y's, we went down 1. So that means we subtracted 1 from the y. So if you start here with this p, we've started at 5, positive 5. If we were to subtract 1, we would get 4, which is what we got. And you can check this rule for every single one. They're all going to be the same. So we're going to write in our algebraic rule. So our algebraic rule, we took our x value and we added 6. For the y, we took that y value and subtracted 1. That's our algebraic rule. You can apply this to any of these points and it's going to work. All right, so let's look at some more. All right, so translations can be represented using something called a vector. So don't get scared by this word. It's just a fancy name for the translation. So you see them written like this. This is a vector. And this, you would say that this image is going to be shifted 3 units right. So this 3 units comes from here. And then 5 units up. So if it's written like this, this is representing our x's and this is representing the y's, or the change in those original coordinates. So since this is a positive, we're going to go that way 3, and this is a positive y, so that means we're going to go up 5. So we can go to any of our original points, slide over 3, and then up 5, and we would get our new point. So first thing we're going to do is just write down how you would say these vectors with words. So if we have a -3 and a +1, the -3 is representing our x's, the 1's representing our y's. So remember, x's always move left and right, and y's always move up and down. So if it's a -x, that means we're going to go that way on the graph, right? Because this way is where our negatives are for x's. So we're going to go that way 3, and then here we're going to go up 1 because our y's get more positive as we go up higher on the graph. So we're going to go up 1. So this would be in words, we would say left 3, up 1. All right, so let's do the same thing for b. So this is our x, the 6. So remember, x's always shift left and right. So this is a +6. So we're going to go right 6. And then this is -2. This represents our y's. Y's go up and down on the graph. So since it's negative, it's going to be down, or subtract 2. Alright, so we're going to draw our new image, or our image, after we've translated this one along this vector. So if these are our x's and these are our y's, that means that the -5 means we're going to shift left 5, so that way 5. And then the 4 is going to be for our y's, so 4 means shift down, I'm sorry, it's positive, up 4. So algebraically, you would say that you have x minus 5, and then here, algebraically, your y would be plus 4. So let's go ahead and draw the new image on the graph. So we're going to start at the point A. We're going to find where A prime is. So we're going to go over 5 and up 4. So we're going to go left 5, 1, 2, 3, 4, 5, and then up 4. 1, 2, sorry. 1, 2, 3, 4, 5, 1, 2, 3, 4. So this is our new point right here for A, and it's called A prime. So we're going to do the same thing for all of these points. So D is going to go over left 5, 1, 2, 3, 4, 5, and then up 4. 1, 2, 3, 4. And I would suggest that you go ahead and label these as you go so that you don't connect them in the wrong order once you're all done. So for B, 1, 2, 3, 4, 5, 1, 2, 3, 4. And then C is going to be the same thing. We're going to go over 5 and up 4. So you want to connect them back in that correct order. And that is your image after your shift. Okay, so let's go to example 4. So example 4 says that triangle T, RST, is translated along the vector V. So this is the vector V. I can label it for you if you'd like. All right, so that's the vector V. We're going to move this shape on this vector. So what are the coordinates of the vertices of the image? So you can tell that these have the prime, so these are our new coordinates. So we have to figure out how we're shifting this over. So we're going to start here and see how far to the right this vector goes. So we would have to go from here all the way over to here. So this is 1, 2, 3. So we went in this direction 3 units. I want to do the same thing going down. So we're going 1, 2, 3, 4. So we went down 4. So we want to just apply that to all of our points. So this R, to find R prime, we're going to shift to the right 3. So 1, 2, 3, and then down 4. 1, 2, 3, 4. So this is R prime. And we'll do this for S. So 1, 2, 3, down 4, 1, 2, 3, 4. And then same thing for T. 1, 2, 3, 1, 2, 3, 4. And then you just connect the dots. So it connects from R to S to T. So from R to S to T, and then loops back to R. Alright, so all of our new points. This point R prime is at 5, 5. S prime is at 9, 2. And then T prime is at 4, 2. Alright, so the next question is asking us what the length of the vector V is. So we'll have this represent the units of vector V. And then it wants also to know what the length of R prime is, that little segment from, let's grab a different color. If you were to draw a line from R to R prime, so from R to R prime, it wants to know how long that line is. So in order to find the length of vector V, it's really simple. We've got ourselves a nice little right triangle here. So we can just set up Pythagorean theorem. So 3 squared plus 4 squared equals whatever our vector squared is. So I'm kind of running out of room, so I'm going to finish over here. So 3 squared is 9, 4 squared is 16, equals our vector squared. 9 plus 16 is 25. And in order to get rid of this little square term here, we take the square root of both sides. So that means that we end up with a vector length of 5. So super simple to find that vector length because you guys already know how to do Pythagorean theorem. Now to find the R prime segment, it's going to actually be the same size because remember we're shifted all of these points, the original points to the new points, the same amount. We shifted them all over 3, 1, 2, 3, and all down 4. So these are all going to be a 3, 4, 5 triangle. All of these points from T to T prime, from S to S prime, those vector lengths or segment lengths would all be the same length. They would all be 5. Alright, so for part C, if XY is a point on RST, what is the corresponding point on R prime, S prime, T prime triangle? So we want to look and figure out what we did. This is kind of like our algebraic rule. what did we do to the x coordinates and what did we do to the y coordinates? So for our x coordinates, we shifted to the right 3. So that means we added 3 to our x coordinate. So we're going to just put x plus 3. For our y's, we shifted down 4. So that means we went in a negative direction on the y-axis. So we took our y value and we subtracted 4. And so that would be our new corresponding point. If you didn't know what the values were, the actual numbers were for this point, we would just take whatever it is and add 3 to the x and subtract 4 from the y. All right, so we're going to name the vector v using the component form. Naming it just means that we're going to write it like this. Okay? So if we shifted 3 and then down 4, it's just a positive 3 and a negative 4. That's it. That's named. All right, and then I'm not going to cover this part right here. It's a short unit, so we're not going to cover this part. All right.